As promised, another brief lecture today. This will be on the languages of computers. I found different ways of approaching this. I guess I'll go through by the generations. You have the first generation language, which is machine code. That was the first language developed. It basically consists of ones and zeros. It is what the machine actually understands at the most basic level. I copied down some machine code from a processor that I use. For example, this. Is the machine code command to disable global interrupts in that processor. You don't get that from the ones and zeros, though, do you? Not so much. I'm sorry? Cleared the global interrupts when in the processor. Disabled interrupts on the entire processor. So a second generation language was created in 1947 by Kathleen and Andrew Booth, as I recall. Assembly code. This translates in assembly code to CLI. Most assembly code instructions are a few letters long, not full words, just abbreviations. This is clearing the I bit, or clearing the interrupt enable bit. Both of these are processor dependent. You change the processor, you change the language. Unless it's in the same family. This is the in the AVR family of processors that's found commonly in Arduino boards and that sort of thing. You learn about those in Comp.org, if I'm recalling correctly. But if you have assembly code written for an AVR architecture processor, and you want to change processors to a PIC controller, which oddly enough is made by the same company, you'd have to change the assembly code. The structure of the processor is different, and the language that it understands is different as well. This was still made things tedious and slow to program. Each machine code instruction corresponds to an assembly code instruction. There's no real abstraction involved. So it takes a lot of code to accomplish just a little bit of processing. When I was teaching CompOrg, one of the problems, one of the assignments was to blink an LED once per second. The assembly code for that reached approximately 160 lines of code. You can accomplish the same thing in a higher level language with about 4 lines of code. So one instruction does one specific thing and nothing else. It does one very small thing, whether it's loading a value from memory into a register, jumping to another part of the program, whatever. We went over last time the instructions for a computer. There's 4 different types: the arithmetic, the logic, the branching, and the moving of data. So it's going to do one of those things and nothing else. So this was how computers were programmed for 10 years until third generation languages came about. First one being Fortran in 1957. Fortran is what's called a high-level language. It used more words and symbols that made programming a little bit more intuitive. Fortran is still used to this day. They use it here on campus. The meteorology folks use Fortran to program weather simulations. Fortran stands for Formula Translation. It is very good for doing scientific computing, serious number crunching, that sort of thing. It has evolved over the years. I don't know what the latest iteration, when the latest iteration came out, but it has evolved over the years. The 1957 version is not what is used now. After Fortran came Lisp. In 1958. This was the first functional programming language. What distinguishes third generation languages is that they are platform independent. When you write a language, write a program in a high-level language, it doesn't matter what processor it's going to be run on when you're doing the writing. When the processor comes into play is when you compile them. So Fortran was the first compiled language. Which means compiling is, of course, you know from CS 1 and 2, compiling is translating your high-level language instructions into machine code that can actually be executed. Like I said, then Lisp came in 58. Algol came also in 1958. And I'm wagering that very few of you have ever heard of Algol. Has anybody ever heard of Algol before? No? It is the language that languages such as C, Pascal, Ada, C++, Java, C#, they're all descended from Algol. That type of structure was pioneered in 1958. And these other languages took that and went from there. They ran with it. In 1972, Prolog was invented. It was the first logic programming language. Each statement in a Prolog program is a form of logic, either associating two items together logically or an if-then statement, effectively. It's a little bit complex to work. The version of Prolog that I used in the 1980s had it where the program flow, depending on what happened, could go backwards up the program. So the logic stream kind of looked like a plate of spaghetti. It was all over the place and kind of hard to wrap your head around how it executed the various instructions and the order in which they were executed. In the 1990s, we got the internet. Them government and university guys finally opened it up to the public in either 93 or 94, I can't remember which. That gave rise to web-oriented languages like Java, JavaScript, and PHP. But they're still third-generation languages. And then in the 2000s, visual programming. Came into play. How many in high school or middle school used Scratch? A few of you, yeah. Scratch is a visual programming language. And what was the other one that LabVIEW? I want to say I used that one on internship once, where you drag and drop blocks to indicate different instructions to be executed. But now high-level languages come in different different highness of level of language. You have the lower level. I'll start since it's lower level. You have the lower levels like C. C++ is slightly higher than that. A language I like to use, C#, is a little bit higher than that. Java. Actually, C# is like if C++ and Java had a baby, you'd get C#. Then you have Python. Is one of the highest level languages out there. Each one is getting more abstract. And this is closer to the hardware. Like in C and C++, you can use pointers, which are the numbers of which are the memory addresses where the data actually lies. So it's still pretty close to the hardware. C#, you don't have to deal with pointers. For Java, not at all, and barely have to deal with data types in Python. These four are strictly typed. Python is loosely typed, meaning you don't have to tell the program at the beginning of the program, what type a particular variable is going to hold. It figures that out when it's run. Some people find it easier to use because of that. I personally find it a little less neat and tidy. I mean, when you specify what type you're going to be using, it seems like you can better anticipate things. That's just my opinion. That's neither here nor there. Then we get into fourth generation languages. Fourth generation languages are domain specific. Fourth generation languages are written for a particular problem domain, like generating reports or writing programs for writing database programs, that sort of thing. But fourth generation are domain specific, not general purpose languages. I saw some names of languages that are fourth generation, and I didn't recognize a single one of them. I figured you probably wouldn't either. Not something I'm going to test you on or anything like that, but there are not very many fourth-generation languages. Some third-generation languages have libraries that make them behave like fourth-generation languages, such as the libraries of Python for scientific computing. That is oriented toward scientific computing and that problem, that problem domain. So it has characteristics of a fourth-generation language, while Python, the base language, is a third-generation language. Fifth-generation languages is a language you don't have to program in. You define a problem, and the language solves the problem. No programmer. Now, has that happened yet? Probably not. It hasn't gotten to that point quite yet. With the advent and evolution of artificial intelligence, we're getting closer to that, but we're not. I don't think we're quite there yet. But you would give it give the language a very specific problem description, and it would solve it and write its own code to solve your problem. So, like I said, I don't know if we've gotten there quite yet, but we're getting there. Kind of an interesting thing. I was having a discussion with someone earlier today about artificial intelligence and how long has it been around? Any guesses as to when the first neural net came into being? 1959. So what is that? 76 years ago? No. Something like that. No, 66 years ago. 66 years ago. AI has been around that long. In the 1970s, the Postal Service was already using it to do character recognition for reading addresses off of envelopes to automate the mail delivery. AI in the cars? Ever since they put computers in cars, they've had AI in them. I was working on my mother's 86 Ford Ranger and reading the owner's manual, and it had an AI system in it. It told you how to reprogram it and retrain it and that sort of thing, but basically it would learn how you drive and then adjust engine performance for the style of driving that you did. So AI has been around quite a while, it's just these large language models and the large neural networks that we have now haven't been possible because of the lag in hardware technology. With the increased, the improvement in hardware technology, we're able to do more things faster. So that's why AI has become so prominent in the past 10, 15 years. But yeah, Lisp was actually developed for programming AI. A lot of AI applications are still written in Lisp, and that was 1958. Neural nets are just one example of AI. There's other types of AI decision-making structures, Q-learning and Markov decision processes and all that fun stuff that if you take artificial intelligence or machine learning, you'll learn about in those classes. But Lisp was developed in 1958 to address that sort of thing and be able to program that. But like I said, as promised, these last couple of weeks are going to be brief lectures. This is no exception. So, yeah, it's a little after 4:30. Have a good day. Let's see here. What is going to be the next topic? Different types of programs. So we'll address that on Wednesday. Have a good day.